Hello everyone. This will be the solution video for exam 1. So let's get right to it. There's a lot of problems to do here. Yeah, so let's see. We got page 1 here. The ski slope. So we've got two payment options. So we're writing two functions. I guess that's the key to this. So option 1 here says $20 per visit. And then we have, oops. Then we have option 2, where we pay $150, but then we only pay $10 per visit. So flat rate and a smaller per visit payment. So yeah, so let's write down an equation for option 1. So what do we have here? $20 per visit. That's the slope. We know that because it's like a rate. We have M, so the units on M would be dollars per visit. So there's your output, and there's your input. Okay. And, well, B is 0, right? We don't pay anything. We don't pay like a membership fee or anything to be part of the ski slope. So we've got an intercept of 0. Short story long, this looks like a very simple equation. O of x is equal to $20 per visit times x in visits. So where x is the number of visits and O is the cost. All right, so that's kind of what I was looking for that one. There's your input and output with units, and that's how you'd go about that. All right, so for option 2, we pay this fee, and then we pay $5 per visit. Now that's sounding sort of like an intercept, right? There's an initial value here that doesn't depend on the number of visits. So however many times we visit, we definitely paid $150, right? And on top of that, I'm going to pay $5 per visit times x, my number of visits. So again, we have T is the output, and the units of that are cost, or dollars. And x, we have number of visits. Okay, so how many visits does it take for option 1 to equal option 2? This is not a problem that you write a table for. In fact, this is college. We're done writing tables. We solve equations here. All right, so let's do it. O of x is 20x, right? There we go. T of x is 5x plus 150, right? Well, how many visits does it take for option 1 to equal 2? So what we mean by that is that when is it going to cost the same to have option 1 or option 2 in terms of number of visits? So this is, the answer to this is not, well, if I do, you know, this x is going to be the same, is what I mean, right? What number of visits makes these two options the same cost? Not, well, if I do 2 visits for this one, that's the same as doing 5 visits for this one. That's not what we're asking. We're asking what x makes 20x equal 5x plus 150. Okay, I don't know, maybe I'll subtract 5x from both sides and end up with 15x is equal to 150, or in other words, x is 10 visits. And that's how that one goes. All right, so we got two answers for this one. So first we have to get it no fractions, right? In the base, that is. In option 2, no negative exponents. Okay, so first of all, let's get this guy simplified. We need to combine all our a's and b's for step 1, right? And so I'm just going to use my standard mode. So it's not the most efficient method, but it always gets me there. So I tend to always convert my radicals into powers first. Next to the -2, a to the -4, b cubed. And then I'm going to wrap that in parentheses and do a 1/3 using our nth root of a is a to the first, or 1/n power. Okay, so now, you know, it might not be the most efficient method every time, but there's nothing wrong with going through the same steps if it makes sense to you. So I'm going to combine my powers next. I'm going to distribute this 1/3 in here. Okay, so doing that, I get a to the -2 over a to the -4/3, and then b to the 3/3. Oh, that's just b to the first power. Okay. Now I'm going to use this guy, right? A to the n, a to the m. Let me write that a little bit better for y'all. A to the n divided by a to the m. Well, that's a to the n minus m. Okay. So that means that what we really have here is a to the -2 minus -4/3. And then that'll be b to the -1 there. So kind of brought everything to the top. So I kind of used this rule too. 1/a to the n is a to the -n. So I used both of these rules in this step right here. Okay. Well, I think that -6/3 plus 4/3 minus a negative, that would be -2/3, no? All right. So then what I get out of here is I get a to the -2/3, b to the -1. Yep. And that's how it does. So this is our answer to part I, right? No fractions in the bases. So the part 2 solution, part II solution, well, we just flip it over. 1/a to the 2/3, b to the first. So those are our two answers for that one. And that's how that goes. All right. Now, this one ain't too bad here. So number 3. So x plus y, number 2 is 8 plus 4, x plus 1. So, you know, I'm sick of these fractions. I'm just multiplying everything by 2. All right. And so what I get there is x plus y equals 16 plus 8 times x plus 1. So if you track that, you'll see that I've distributed the 2 to all of these terms here. And I did get rid of my fraction, which is, I don't know, nice. All right, so let's simplify this side a little bit, because I can do a little bit better. 16 plus 8x plus 8. All right, so then x plus y is the same thing as 24 plus 8x. So that means that y is the same thing as 7x plus 24, subtracting the 1x over there. All right, that's the answer to that one. So it's a bit of a doozy. They're simplifying some, you know, well, we got to do it sometimes, so it's good we practiced it, I guess. Yeah, looks good to me. All right. Is the relationship between profession and income a function? Why or why not? So there's two good answers for this. And so it's definitely not. And you can think of it in two ways, because for this class, the rules we use to map functions are in general mathematical. So you could argue on that point. The profession is not quite a mathematical object. But let's say you go deeper. You say, well, look, profession does in general determine your income. You're right, but we have this concern. If I'm a doctor, depending on where I live and what kind of doctor I am, I could make 80K. I can make 450K, right? My salary is way different. Likewise, if I'm making 450K, I could be a doctor, or I could be a CEO, right? So either way we take it, we can have one input leading to several outputs. So we can't really use this as a functional relationship. Now, a lot of people did say it was a function and did say that's because profession correlates to income. You're right about that. We could write a function that says doctor and that has profession in one column and average income in another column. I mean, that's a wishy-washy function, but it works. You could do one better. You could say years of school over here and average income over here. And this is a great numerical proxy for profession, it turns out. And since we've taken an average here, we've collapsed all of the different answers into one. So if I asked you this question, if years of school versus average income was a function, you could say yes. But unless we collapse it using some sort of averaging or something like that, we're stuck with this condition, where if I'm a doctor or I go to school for 6 years, I could make one of several incomes, right? Not quite the same thing. Okay. Number 5 here. Range and domain. Let's see. Range. So first thing, mark this point. What do we got here? There's 1 or minus 1, right? There's minus 1.5. This is close enough that I'm going to call this point negative. So that would be negative 2.5 down there. Down here is negative 3, right? So I'm going to call that negative 2.25. Looks like about a quarter. Whoops, but I've already made a mistake, you see here. What am I doing wrong? I'm putting my ordered pairs backwards. So I'm going to call that point negative 1.5, negative 2.25. And so, yeah, I'm going to call this 1.5, negative 2.25. Okay. All right. That's 1, so that's a half, so that's a quarter. Okay. So I've marked these points, and if you do this on your test, I no longer have a concern, right? I don't have to try and read the graph and get in your head and try and figure out what points you were picking and how you were picking them. Now that I know what your estimate is, it's a lot easier to grade. It's a lot easier to figure out what you were thinking and whether or not you were on the right track. So, yeah, all right. So from this, I can see that my range goes from about negative 225 to, well, exactly 4, it looks like. And I'm using square brackets there because I do think we're hitting those points. It's kind of an estimate thing, but I would have accepted round or square on that. All right. Now, so the filled dots here for the domain definitely indicate that it goes all the way to -2 and all the way to +2. So in this case, square brackets are mandatory. 2 to 2. All right, so there's A. All right, where is it positive and where is it negative? Well, you know, my favorite answer for this that doesn't get any credit is, hey, look, positive, negative. Yeah. For what x values is the function positive is the question here. So look, looks like these points are -1, 0, and 1, 0. So this is no good. This is not a way to get good credit here. Excuse me. But you know, I can look at this here and say, well, the function's output is definitely positive when x is between -1 and 1, right? Here's x equals -1. Here's x equals 1. Sure looks like the function is above 0 on the y-axis there. So to answer this positive part of the question, I would say from x is -1 to x equals 1. This would get you most credit. But if you really want to nail this thing, you got to give me interval notation. -1 to 1. There you go. And it's negative, well, where it ain't positive, right? And that would be from -2 to -1, and again from 1 to 2. All right, there's part B. Part C, where's the function increasing? Well, it seems to turn around right here, and turn around right here, and turn around in the middle right there. So there's definitely decrease, increase, decrease, increase, right? So I should have 2 answers for increasing and 2 answers for decreasing. So this will be number C. So I'll do decreasing first. Decur. It looks like from -2 to this point, which I've labeled as x equals -0.5 or 1.5. So decreasing from -2, from x equals -2 to x equals -1.5. And again, between x equals 1 and x equals 1.5, right? Oh, I'm sorry. And again, from x equals 0 to x equals 1.5. 0, 1.5. All right, well, where is it increasing? Well, kind of where it's not decreasing. So looks like from about -1.5 to that point in the middle there. So from x equals -1.5 to x equals 0. It's like we got this complement thing going on here, you know? And again, from 1.5 to x equals 0. So again, these are all x values, right? The range of x values that makes this true. Concavity. Well, it's definitely holding water this way, right? And it's definitely holding water this way. And it's probably dumping water between here and here, right? Okay. So that hinges on these points, -1, 0, and 1, 0. So what can I write here for part D? I can write concave down from x equals -1 to x equals 1. And then it's concave up kind of elsewhere. Concave up. So from -2 to -1, and from 1 to 2. All right. And part E, one more part. Identify the minimum and maximum. Well, just so we've done it all, let's go ahead and mark that top point, max, at 0, 4, min. Well, I mean, you could get philosophical about it and say, well, it's got 2 points that are the same, so it doesn't have a minimum. It has 2 minimums, right? Well, that's a little philosophical for me. What I would write is this. I would write plus and minus 1.5, right? Because it happens that x is minus 1.5 and x is plus 1.5. And both of those give you the answer negative 2.25. So that's how I would write that answer. All right. Page 3. Here we go, guys. Okay, so this one's a lot of words for a very short answer. So Phil performs a linear regression on their data and is thrilled to find a correlation coefficient of 0.998. They run to tell their research advisor that they have found a causal relationship, meaning they have found a correlation between two variables, and they have concluded that one thing causes the other. This is incorrect, and it's incorrect simply because of this fact. Correlation is not the same thing as causation. Two factors could be caused by a third factor that would make them correlate but not cause each other. Yeah, it's that simple, y'all. Alrighty. Yeah, all right, trig time. So we got a 40-foot ladder. So we're going 40 feet like that. And we're leaning up at a building. And the angle we make with the ground is 80 degrees. That's where that comes from. That's where that 40 comes from. And how many meters up the top of the building is the ladder? All right. So we're going to have to do a unit conversion when we're done with this, right? Okay. Well, what does this look like to y'all? Looks like a hypotenuse and an opposite, right? Hypotenuse, opposite. Well, that corresponds to some old hippie, right? Okay. So I'm going to use sine of 80 degrees is going to be the same thing as this thing we don't know. Let's call it y. Y divided by this thing we do know, a hypotenuse, 40 feet. All right, so I got 2 out of the 3 things I need. And it turns out that y in feet is going to be the same thing as 40 times sine of 80. Then I get 39.39. Does that surprise anybody? 80 degrees is a lot. That's almost a right angle. Almost all of the length should be in the height here of that ladder. So, well, that's what came out of my calculator, so it must be right, right? Okay, so now I have this problem. 39.39 feet times, well, what do? 1 meter is 3.28 feet. 3.28 feet, 1 meter. And I divide my 39.39. 39.39 divided by 3.28. And I get 12.009, which I saw a lot of people round into 12.0001, which is good. Check. That is a correct rounding.
Yeah.
So good job on that. Yeah, this was not too bad. Most people got in the groove on that one and had no trouble. All right. So here we go. 48 cubic feet of gravel. So feet cubed, right? How many cubic yards is this? Well, I'll show you the quick way. So I would have done it like this. 1 yard is 3 feet, right? But I got cubes, so I better cube both, right? And that would get me 48 feet divided by 27, sorry, feet cubed times 1 yard cubed. 47 over 27. So 48 over 27. be about 1.78 yards cubed. Okay. So the revenge of the linear equations here, folks. Couple ways to go about this one. Several ways to go about it. But, or at least several ways to go about these. This one's pretty straightforward. We're not given the intercept, so we better use point slope form. And so let's just go to it. We call this x1, y1, this x2, y2. And we'll just fill in the pieces, right? So I have -2 minus 2 is the same thing, or is divided by 2 minus -1, right? So we get a -4 on top and a +3 on bottom. So our slope is -4/3. Okay. Now let's use our trusty point slope form here. So x1 is 2, or y1 is 2, x1 is -1. Oops, we know what m is now. -4/3 times x minus -2. Excuse me, guys. -1. Okay, so lots of minus and negative going on in this problem, but so we end up with y equals -4/3 x minus 4/3, right? Plus 2. But I got another way to write 2. 6/3. Lots of thirds running around in this test. I wonder if I had thirds on the brain when I was writing it, I guess. So y is -4/3 x plus 2/3. Yeah, there we go. Okay, so that's A right there. Now, B, you might not believe it, but B can fit in this little box here, because all we need is a function, any function at all. Well, I better get full credit for myself here. I wanted to call this f of x, not y. Okay, so g of x. G of x can be any function that intersects f of x. So I saw a lot of people using the +3/4. So using the one that intersects at a perpendicular, at a right angle, you know, the perpendicular slopes idea. That's great. That's great. I'm going to do something a little bit easier. 1x plus 2/3. Because anything with a different slope than -4/3 will intersect this. The best answer I saw that didn't get 4 credit was, well, just make g of x exactly the same as f of x. Okay, it does intersect at every point, but I did say a different linear function. So next best thing, try 1x. You know, why make it complicated? And use the same intercept. Oops. And use the same intercept. Use the same intercept so that you know what the answer should be when you solve for their intersection point, right? They should intersect at their intercepts. Okay, so here's part C. Won't take much. -4/3 x plus 2/3. When is that the same thing as x plus 2/3? And if you squint at this, you know the answer already. Negative number times something equals positive that something, right? When does that happen? When is -x equal to x? When is 5x equal to x? Only when x is 0. So you already knew the answer, and there it is again. But so that's the conceptual. Let me, that page below, page below, plain paper. Okay, so let's just do the solving to see what happens. Negative 4/3 x plus 2/3 is equal to x plus 2/3. All right. Maybe I'll add the 4/3 over. Might as well, right? Okay, so 2/3 is the same thing as 4/3 x plus 3/3 x plus 2/3. That's the same thing as 7/3 x. Oh man, a lot of adding fractions in this problem. 2/3, 2/3 on the other side. Wait a minute, the next step is to subtract 2/3 minus 2/3. Negative, positive 7/3 x is equal to 0. Well, there's definitely only one way to make that true. So what we knew kind of by intuition here, by reasoning it out, is indeed true by performing the algebra steps. All right. Now we're getting through this guy. All right, so I don't know. Thought about not putting this one on here, but I thought you could handle it. While we haven't emphasized function notation as much as I have in other classes, it is definitely covered in the book. We've definitely talked about it. So here it is. So either, right, find either the given values or determine if the ordered pair is a solution, right? So ordered pairs represent solutions to equations. So I'd like you to, if you see this, plug in 7 and run. If you see this one, confirm to see if that's a solution of the equation. But the mechanics of it are very similar. So for part A, g of 7, well, that means I pop 7 in wherever I see x, right? 7 plus 3, 7 minus 2, 10 over 5 is 2. Okay, so the answer to that is 2. B, now I'm given an ordered pair, so I need to confirm that if I plug in 3, I do indeed get 6. Well, let's check it out. 3 plus 3, 3 minus 2. That does appear to be 6 divided by 1 is 6. Check. C. Now this is another plugger. 1 plus 3, 2 minus 1 minus 2 is 4 over negative 1, negative 4. All right, so that's the answer to this one, right? So it goes 2, yes, negative 4. And so that's how the answers go on these. And all right, so this for the next one. So this is another does g of 4 question mark equal 4? Well, we know what g of 1 is, but that doesn't tell us anything about this 0.44. So we're going to have to compute 4 plus 3 divided by 4 minus 2 is 7 divided by 2 is in no way the same as positive 4. So the answers for this go g of 7 equals 2. No, I mean yes. G of 1 is negative 4, and no. Yeah, all right. Recommended pitch steepness for a shingle roof is 2 to 12. So that means 2 up, 12 over. All right, so we got a picture, right? So it did happen. All right, that's good. The most uncomfortable thing I write on papers is pictures or it didn't happen, but it's very important to write pictures for trig. What angle does this correspond to? It does not correspond to a right angle. Every you can make this right angle relationship with any pitch, right? So it doesn't correspond to a right angle. We're talking about this angle here. You know, what's the rise of the slope? What angle's the slope at? Well, I think we got a function for that. This looks like an opposite. This looks like an adjacent. I think we can tangent this sucker. So tangent of this unknown angle is 2/12. Well, that's all right, because I can take the arctangent of 2/12, and that'll get me that angle inside there. And if I do that, I get an angle 9.46, about 9.5. Okay. So now, I think so. This phrasing, there were two correct ways to draw this picture, and two ways that matched the description well enough. Slopes up at 20 feet on a side. That means that, to me, that means the slope is 20 feet. So we got a house, and it's got two sides, because most houses have a, that peaked roof kind of deal. That's what I'm looking for here. 20 feet on a side, and that's the house I drew. A lot of people, enough people that I felt like it was a reasonable interpretation of the problem, said 20 feet up, that means how high up did it go? So if I have a house, it's got a 20-foot rise in the roof, how long is it? Both of those are parsing the words as correctly as you could parse them. It's kind of an ambiguous wording. So let me add a page below, and we'll get into the solving of it. 9.46, let's remember that number. So if we drew our house like this, this angle is 9.46. And so that angle would be 9.46. All right. So here's our question mark. And the length of the house, say L, is going to be 2 question marks long, right? Okay. So how do I find the question mark? Well, in this case, I've got a hypotenuse. We're given hypotenuse and theta want adjacent. Okay, so that's sounding like adjacent over hypotenuse. That's like called another hippie, right? Okay, so all right, cosine 9.46 degrees is the same thing as, we'll call it question mark divided by 20. So then question mark is equal to 20 times cosine 9.46. 20 times cosine 9.46. And that's 19.73. So kind of with this problem and with this one, we're encountering that extremes of the angle, one of your legs can start looking a whole lot like your hypotenuse, but it is not, in fact, the hypotenuse. What we're discovering here is that this picture is grossly out of scale. To really draw this, it would have to be like, and you can't really see much when I draw it like that. So, what we find there is that the picture is exaggerated. Okay, so that got us the right answer. Oh, but we have to double it, right? Times 2, 39.46. 19.73 times 2, 39.46 feet. All right, so what if you drew your picture the other way? What if you said, no, I'm at 20 feet up? Okay. Well, this angle doesn't change. We got that from a different part of the problem. That's still 9.46. And we're still looking for this question mark, right? Okay, so now we have a tangent. We have a tangent of 9.46 is going to be the same thing as opposite, 20 feet, over adjacent, question mark. So if we multiply both sides by question mark, divide both sides by tangent, I'm going to get that question mark is the same thing as 20 feet divided by the tangent of 9.46. If I do that on my trusty calculator, we get 120 now. Big difference in answers, but it's a big difference in the way we drew the picture, right? And so then, well, now you have to ask yourself, what kind of house am I drawing here, right? Is this a shed roof like this? I don't know. We got a nice slope up here, you know, walls of the building like that, maybe doors over here. You know, is it a shed roof kind of thing, or are we talking about like an old-fashioned, you know, house you might have drawn in kindergarten with, you know, steep roof on each side, maybe a little attic window up here. Yeah. Well, it depends on the picture you drew me. If you drew me something like a shed roof, I tried to check your work like a shed roof. If you drew me something like this, I tried to check your work like you were drawing a kindergarten house, if you will. So, you know, I really tried to get in your head on these. If you feel like I didn't get in your head enough, talk to me and we can get you some points back. But yeah, that's how that one went. Oh man, more trig. Oh, this is exhausting. Okay, all right. So what do we need to know here? We got big A. So why don't we just write a list? A, B, C, A, B, C. All right. Don't know angle A. Bummer. Oh, angle B is 55. That's nice. Angle C is 90. It's even given in the problem. All right. So how do I find angle A? By any means necessary. In this case, I'm going to subtract from 90. Oops. 55 degrees, right? So we know that if the three angles of a triangle add up to 180, and half of that's taken up by C, I know I can subtract 55 from 90 and get A, and I would get 35 degrees. Right? I don't know, I'm bad at arithmetic. 35 minus 55. Yeah, okay, definitely 35. Gotcha. All right, what else do we know? I think we know angle C, or side C, excuse me, that would be 4 inches. All right, so it's down to A and B. That's the only things we don't know yet. Depending on how you go about this, there's some decimal place differences, but I'm going to do a solid trig because, actually no, I'm going to find one angle with trig and one angle with the Pythagorean theorem. Why not? All right, so I got a hypotenuse, 4 inches. I got an angle, 55 degrees. So I'm going to say that A is equal to the cosine, I'm going to say A divided by 4 inches is equal to the cosine of 55 degrees. All right, so then A is the same thing as 4 inches times cosine of 55. So cosine of 55 times 4, 2.29 inches. Okay, so I'm sure y'all would agree with me if I said that, well, 4 inches squared is the same thing as A squared plus 2.29 squared, right? Or at least close. I'm staring at my calculator, and there are definitely a lot more digits than 2.29. So if you do it, if you found the other side with, you know, there's going to be some decimal errors here, but point is, you get within 2 decimals, we should be okay. So I'm going to rewrite this. I'm going to say 4 squared minus 2.29 squared is the same thing as A squared. And I'm going to square root both sides. And since we're talking about distance here, I know that distances are positive. Like distance between 2 points is pretty much always positive. So I don't have to worry about some sign ambiguity with the square root here. I can just go ahead and take it, extract the positive root, and go for it. I'm actually going to keep all the digits in my calculator here. So I'm just going to go answer squared. And I'm going to go 16 minus answer. I'm going to take square root of answer. And I get that B is about 3.28. And I got that from solving that sucker, or simplifying that sucker, I should say. Okay. Yeah, so back to like very first week talking about percentages and counts and how to read a bar chart with percentages on it. So now we're dealing with undecided students. So for part A, you know, let's see, that's 5, 6, 7, 8. Excuse me. I'm just going to call it 8%. It's very close. And if I name it 8% right here, we can't get confused, right? Because what I really want to see is whether or not you can convert this into an absolute number of students. So if you wrote 7 or 8%, it didn't matter so much as if you knew to do this for part A. If you knew to do, I had 26 students total. If I multiply that by 0.08, I get about the number of students, the undecided students in the class, right? So 26 times 0.08 or 8%. That's 2.08. Between 2 and 3 students, closer to 2, right? But we can't like count the part of a person. I was pretty lenient on this. If you said this ended up being 3, that was okay. If you said this was 2, that was okay too. Because really, maybe that's just an error. Maybe there were only 2 students. You know, who knows? How many more exercise science majors were there than undecided? All right, so now we got to go over here. You know, I'm just going to call that 15%. I know it's a little over, but you know, this is not a graph reading class. This is I want to make sure that you can convert from percentages to counts kind of thing. So if you marked that 15 or 16 or 15.5, I followed your work and counted it right if you were right. So again, there's a couple ways to go about this, right? We know there's 2 or 3 students. I'm going to compare the percentages for it, right? 0.15 minus 0.08 gets me 0.07. This is the percent, or this is the decimal difference, right? 7% is of students is the difference between the number of undecided and the number of exercise science. So why don't we just go 0.07 times a 26. And that gets me a 1.82, or about 2. So kind of no matter how you slice it, you get somewhere between, well, you get about 2 students difference. Then let's see if we've done it the other way, right? So 15% times 26. That gets me 3.9, or about 4. So if I took the difference, if I picked this number, you know, I would have gotten a 2. Picked this, I would have gotten a 1. In general, I tried to follow your work and count right if you made sense with what you were doing and how you picked these percentages. Because the goal here was, can you convert these into numbers? And most people did pretty well on that, so good job. All right. State the definition of a function. So I've been hammering this hard, guys. I think I really have. And for the most part, people had it down pat. So it's a rule. And in our class, we like it to be mathematical. But it's just a rule that takes each input to one output. So let's talk semantics for just a second. I say each here, and a lot of people put one, and they underline it. One input, one output. I don't know if that puts the emphasis on the right syllable, though, because each input has to have one output, not one output has to have, or one input has to have one output, right? It's each input. There's a semantic difference there, no? Because here's a function where one input has one output, and all of the other inputs have two outputs, right? Yeah, so this ain't a function. So I can fit this description. One input has one output without satisfying the definition of a function. So I prefer the word each here, or for every input. Semantically, one doesn't quite do it. Yeah, okay. So explain why these are not in scientific notation. Well, I think we even had this on our crib sheet, right? For scientific notation, it's got to be n times 10 to a little n, right? And this big N has to be somewhere greater than 1, less than or greater than or equal to 1, and less than 10. Strictly less than 10, greater than or equal to 1. And little n, anything at all. Well, any whole number at all. Let me write that. Any whole number. They can be positive powers, negative powers, just as long as they're a power. I'm happy. Okay, so how do we do this one? Well, 0.7, I need to multiply that by 10 to move the decimal place, right? So I'm going to multiply by 10, but I can't change the actual value of the number, so I can really only multiply by 1, so I'm going to multiply by 10 divided by 10. That's still times 10 to the third. And I'm going to cleverly group things. So that turns into 7, and that turns into times 10 to the second, right? 10 to the third divided by 10, 10 to the second. So that's how that goes. And it makes sense, right? We made this number bigger, so this number had to get smaller. Now we're going to make this number smaller, so this number has to get bigger. So I'm going to move my decimal once to the left, which means that this gets one bigger there. There you go. So that's how you fix them. Number 17 was a whole bunch of extra credit. A lot of people took advantage of it. I saw some really cool discussions about, various techniques. And in general, people did pretty well on this exam. I don't think I could have hoped for better. I think you guys are doing just fine. I think with corrections, everyone's going to be pretty happy with their grade if they consider the amount of effort they put into getting it. And thanks so much, guys. We got about a half a semester left. I hope it goes as well as the first half did. Thanks, everybody. Have a good week.